Welcome back. I am the ambitious tech developer, and today we are actually covering chapter 9 in the book Object-Oriented Thought Process. Chapter 9 actually is building objects and object-oriented designs. Okay, so in this we will actually be covering the two different types of composition that there actually is. These two types are actually built either way, and they are aggregation and association. We'll be learning the difference between them and how to use them properly. Aggregations and associations can be used together, and associations can actually be built on aggregations. Okay, so one quick note I want to mention about composite relationships. We have to remember composite relationships has a computer has a mouse, right? Car has a tire. Okay, building phases. One main advantage of using composition is that it allows you to build complex systems from smaller subsystems. The subsystems can be built independently, tested independently, and also maintained independently. Once the subsystems have been built and tested, all the subsystems can be put together to build the complete system. Pretty easy, right? It's like maintaining one little piece at a time, and then at the end, plug it all together. Aggregations. Aggregation means that a complex object is composed of other objects. A good example is a car. So this is basically the main definition of composition, which is basically a car has a tire, right? So it's one big object built by smaller objects, right? So I'm gonna give you guys a quick example that I want. So basically it's a class of car, right? And then it is related, well, car has a steering wheel. I'm just going to abbreviate it to the SW. If I'm correct, actually, the UML symbol is a little diamond at the end, not a arrow, but a diamond. So this basically says that car has a steering wheel, as well as a window or whatever. W for window. Hope you guys can see this. Window, right? Car has a window and car has a steering wheel, right? So that's basically aggregation. It's basically what we have thought of composition this whole time. So then I guess the new one that we are actually presenting in this chapter is associations. Associations are objects using other objects to perform a service. A good example of association is a computer setup. The CPU uses a monitor to allow the user to view the output of the CPU. The CPU also uses the keyboard to allow the user to type into the CPU. Associations can be built on aggregations. If you consider the computer setup example, the CPU itself is built on other objects like wires and chips. The best part about associations is that one object can be replaced without affecting the other objects. So as you see in that little image there, which I'm going to give you guys another example here. Okay, actually I should leave that. Let me see. Give me 1 second. Okay, yes, I'll leave that there. I should have done a little bit more that way, but okay, so now I'm gonna erase it. I'm indecisive. Yes, I know. It happens. Oh well. Okay. Cool. So remember how aggregation looked, right? So it was one object within another object to build a bigger object, right? Well, association is actually separate objects that allow those objects to interact to get something, to achieve a main goal, I guess, okay? So, as in the CPU, I'm gonna draw a quick CPU, I hope you guys can see it. Okay, so this is my monitor, right? It has a little stand. You can see that? Perfect. How's that? Does that look good? And since I'm in Ubuntu. For all you Ubuntu haters, don't hate. I'm just kidding. Appreciate, brother. Okay, so that is my monitor. You know, my keyboard, right? Right? It's whatever. Should I release all? Yeah, whatever. Okay. Cool. Gravy. Okay, so now, and this is my tower, my CPU. This is the main. This is the button right there, and this is the CD, USB, whatever. What else can I have? Okay, I don't know. I want to have my fan in the front on this one. You know, why not, right? It's a little circle. Okay, cool. So what association is basically one object using another object to perform a service for it. So in this example, CPU is using the monitor to provide a service for it. It is allowing users to actually see whatever the CPU is outputting, right? It's using the keyboard to allow users, let me put a user actually, this guy right here, you know, a little bit here. It's allowing users to actually use the keyboard to input into the CPU. The best thing about associations is that you actually can replace whatever you want without affecting the rest of the objects, right? So you know what? I don't even like this tower anymore. So I can replace it, or you know what? It broke down, or it rained and I left it outside. I don't know, right? So I don't like that one. I want something else, you know, like that was a Dell, by the way. So now I'm gonna try an HP. This one, the HP, it looks similar, but it has the button in the bottom. Great. And it doesn't even have, that's it. It's just a tower, right? It has nothing on it. The monitor and the keyboard are not affected in any way, shape, or form. The tower is still using the monitor and still using the keyboard for the same functions that the other CPU was using it for. So in this way, we could work on the monitor. If it breaks, we could take it apart, take it to the shop, replace it, whatever we need to do, fix it and plug it back in, or plug in another one. Same thing for the keyboard. If it breaks, it gets wet, whatever, you spill soda, you spill coffee, whatever, pizza, you know, pizza and soda, whatever. It breaks, you can replace it. Same thing for the CPU. So that's basically aggregation. That's the benefit of aggregation. I mean association. Okay, so the next is avoiding dependencies. When using composition, it is best if you avoid making objects highly dependent on one another. One way to make objects very dependent on one another is to mix domains. An object in one domain should not be mixed with an object in another domain except under certain circumstances. Okay, so this is going to be my homework. I'm going to actually attach it to the post in the bottom because I was looking over this yesterday. So make sure you look at the additional notes and I'll be posting what they mean by domain. Although by the way it's used, I'm thinking it's a script, a file, an independent file, right? Next, we have cardinality. In their book, Object-Oriented Design in Java, Gilbert and McCarthy described cardinality as the number of objects that participate in associations and whether the participation is optional or mandatory. To determine cardinality, Gilbert and McCarthy asked the following questions. Which objects collaborate with which objects? How many objects participate in each collaboration? And is the collaboration optional or mandatory? Optional associations. When dealing with optional associations, it's necessary to check to see if whether the association is null by using conditionals rather than returning something automatically. Now, I feel like I gotta break something down on this. I gotta explain a little bit further because I didn't actually put images on those notes. So, what I am going to do is I actually want to draw a little diagram for you guys. See if it allows. Let me find it. Okay, so one segundo. Okay, so cardinality is going to make a lot more sense with in the next chapter, but I want to make sure I draw this diagram for you guys just so you guys give you guys an understanding, because the next chapter is not going to be out until a couple days. Okay, so oops, sorry. Okay, so that's a little better. So we're going to draw a couple classes. Now, I'm not going to go into detail as the way you do it in the book with the attributes and the methods. So I'm just going to put the name along. This is person. I swear I can write better in paper. I can't write in boards to save my life. Okay, this is going to be employee. I'll put EM for employee, EMP for employee. Okay, now I'm going to put spouse, right? Spouse. I don't even know if I spelled it right, whatever. Okay, now we got child. I'm actually thinking of cutting this diagram a little down just so I can show you guys. Okay, whatever. Can you guys see the bottom? Okay, perfect. I think you guys can see it. Put 2 more classes. Okay, perfect. Okay, this is going to be job description. And this is going to be division. Okay, so now imagine this is all populated with attributes and methods. Okay, so an employee is obviously a person, right? So inheritance, we're using inheritance. Remember, inheritance is a white arrow, right? An arrow with the white arrow tip or whatever. Spouse is a person, employee is a person, child is a person, right? Now, cardinality is used by a solid, well, that's not cardinality, that's basically, that means that they have a relationship together, right? So that's cardinality. Okay, so cardinality basically means that an employee could have one spouse, right? Or at least where I'm from, right? So the way we represent that is by putting a 0, ... 1. That means it's a 0 to 1 relationship. So an employee could have one spouse. Now, but an employee could have many children. Could have 0 or many children. So that's 0, ... n. N would be for variable. It would be like a variable, like a placeholder. So it can have many, 0 to many, okay? 0 to many. Now, an employee can have one division. He can only work in one, he's only working one job, right? So this would be just a 1. Okay? Just choose. Set standards, try to make it look like a 1, right? 1. Now, but an employee can also have many job descriptions. For instance, a manager could be a cashier, a manager could be a warehouse worker, a manager could be a stocker, or whatever, right? So on and so forth. So, but they at least have to have one job description because they're an employee. If they were unemployed, they wouldn't even, well, technically they wouldn't be here, but whatever. It would be 1, ... n. That means that's 1 too many. Okay, so that's basically cardinality. Cardinality basically means the relationship between 2 things, right? And whether it's optional or not, which I believe that's exactly how the book says it. Okay, anyways, so basically what they're saying with the optional association is that in your code, you want to make sure that instead of passing a single function a method, a regular, let's say public public, let's just call it boot, whatever. Instead of just doing public boot and then a relationship of whatever, return. You guys know the drill. Return whatever, job description. Oh, well, actually it's spouse, because spouse is optional. 0 to 1, right? It's optional. Job description is not optional. Job description is mandatory because it's one to many, right? So it has to have at least one. Division, it's also not optional. It's mandatory because they have to at least have one, right? And child, well, that's optional as well because the employer can have 0 to many children, right? So 0 to many, right? So the optional ones are child and spouse. And we can tell because of this, right? So what they're saying by in optional association is basically instead of returning, let's say, spouse, instead of returning spouse just like that because it's optional, you would first want to make sure that that is actually not null, that actually holds some value, because this would actually break your code. So you might put a conditional in there, and if else, of course I'm not going to delete, we're already pretty far in here, but if else or whatever, right? You put an if else, while, any type of condition. So that's basically what they mean in optional association. Now, in conclusion, I made this simple, very quick. An aggregation is a complex object composed of other objects. Simple enough, right? That's basically the whole car has a wheel, car has a door, car has a window, car has a gas tank, right? So that's a lot of objects used to create a bigger object, right? An association is used when one object wants another object to perform a service for it. Okay, so that's basically with the whole computer, right? CPU, we use Windows to display. CPU uses keyboard for input. Okay, and remember, it is necessary to check for optional associations using conditionals. That's basically this. Check before you return anything. You gotta make sure that everything's good. You don't want your system to crash. So that's it for now. And I did make you guys a promise that I was gonna look into the whole domains in avoiding dependencies. So at the bottom of the notes, I'll make sure to include it. Until then, see you in the next chapter.